Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back working on the metal planer restoration, and we're going to be working on a casting that I just got back from Windy Hill Foundry that we're going to be hopefully converting over to a bevel gear that we need for the elevation raising and lowering on the machine. The original bevel gear that was on there is missing a couple of teeth. Well, not completely. One tooth is about half gone. I got a couple other teeth that are maybe a quarter gone. I'll show you here in just a second. But I decided we would try to reproduce this part and make it like it needs to be. So let me zoom you in here to show you what we got and show you what the project of the day is going to be. So here is the bevel gear in question, and you can see we're missing about a half a tooth right here, and we're missing the front of a couple of teeth here. The machine was that way when I got it, and I just decided, hey, we would try to make a new one. And to do this, I could have just machined this out of a piece of Durabar, but I decided that I would have a casting made, so I drew up a pattern in Fusion 360 and 3D printed a pattern, sent it over to Clark Easterling at Windy Hill Foundry, and he sent me back a casting here. We cored it so there's a hole all the way through it to start out with. I will say that Clark had a very difficult time with this particular pattern. It was giving him a lot of trouble filling up all the way up to the very top up here. He tried vents, he tried risers, he tried all kinds of things, and eventually he got me a good casting. Unfortunately, the casting that finally came out good, the pattern had shifted a little bit in the molds. I'm not sure exactly what happened. They didn't line up exactly right, and I think that we got enough metal in this that I can clean it up over on the lathe and it's going to be fine. Clark was actually, I think, a little bit embarrassed with the casting, but it was giving him such a hard time, he just decided that he would send me this one to try before he tried another one. So we're going to take this casting over to the lathe, and I think what I'm going to start out by doing is seeing if I can clean up the front side of this. It is oversized, so I got some extra metal in there. I'm hoping I got enough there with that little offset that it will clean up fine. I think it will. And I told him that. I told him, yeah, just go ahead and send that one to me before you try to make another one, and let's see if I can make this one work. He was more than willing to try it again and get a better casting. But I said, well, before you do that, let's just try it out. So over to the lathe, guys. So we're going to go ahead and just chuck this up over here on the rough casting on the shank side. I know we're going to be getting a lot of run out. You always get a run out with a casting, but this one's going to be probably pretty excessive. But I'm hoping, again, that we'll be able to clean it up and have something to work with. Let's see what that looks like. I'm just going to kind of shuffle it around in the lathe and see if I can get a place where it's running a little bit truer to start with. The truer I can get it to start with, the less material we'll have to cut off of it to get it to clean up. Let's try that. That's better. That's actually probably as good as we're going to get it. All right, let's see what we can do here, guys. The hole's running pretty true. I'm going to start by just facing the front of this and get it cleaned up. See what we got. It's mostly cleaned up except around the edges, so I think what I'm going to do is go ahead and set my taper here and see if I can get this to clean up. I think once I got those two surfaces cleaned up, I can determine whether I'm going to have enough material in there to get a good casting. So let me get my compound shifted around to this angle and we'll get ready to roll. I want you guys to see the setup here. I have rotated the compound around to the angle, which the face angle for this particular gear is 29.4 degrees. So, you know, my degree scale down here only measures in 1,000th increments, so I'm kind of just estimating the 0.4 part. But right now I'm just kind of roughing it to get it close, so I think we're fine. And we'll just use the compound to come in here and we will get that angle put right in there, hopefully. So let's come in here. We're just barely touching right there. Take a little bit of a cut. I'm taking light cuts right now, guys, because that back part is a rough casting and it's not really seated as well as I would like in the jaws of my chuck. So I'm trying not to be very aggressive with my cutting here, because if I am, I could move that part around and that would kind of mess things up for me. Take a peek at where we're at. I know we've got some areas and we're not hitting yet, but it is cleaning up. So we got to get down in there. And we're getting down close. I don't think we're quite there yet, but we're getting really close now. All right, it's got a few little holidays in there, but nothing significant. I'm just roughing things out right now. We're not trying to get down to the finished dimensions. Let me make sure we're going to have enough meat in here to get this casting done. Let me do some measurements. I'll be right back. Guys, the next thing I'm going to do here is start boring that hole out to get it running true. And the idea here is that I will turn this on a mandrel, so I'll have something where it's turning on the shaft on the inside. That way when I do all my finish turning, it'll be running perfectly true to the bore, which is ultimately the final goal here. So I got a boring bar. It's a smaller boring bar we'll start out with. As we get it enlarged, we'll probably go to a larger boring bar that's going to be a little stiffer and give us better, won't be flexing as much. But we got to start out with that one because of the hole size. There is a couple of places in there where there's some, the hole's not perfectly round all the way through. There's some little slag pieces in there I got to get out. So you'll notice the first couple of passes here, I'm really not all the way over to the edge, but I'm just going to take my time and get it cut out. I can hear it hitting those little pieces in there. You can hear it right there. We're really not even cutting except for just knocking out some of that waste material in there. Another pass. Again, we're just kind of cleaning out that hole right now. I'm just feeding in by hand. Out here, take a little bit more of a cut this time. Now we're starting to cut in some places in there. We're opening it up. I don't think I'm quite cleaning up all the way around yet, but we're getting really close. Getting a rough measurement, we're about 800 thou. Ultimately, we're going up to a little over an inch. Let me see if I can get a little bit larger boring bar in there and go ahead and swap those out. So we've gone from a smaller boring bar to just a larger boring bar, and what that does is it just gives me more rigidity in there. The smaller your boring bar, the more it's going to flex. The larger, of course, the better it's going to turn. So we've got room now for that one to clear. So let's come in here and touch off with it. And make a pass. So as far as the bore size goes, we want to match what was in the original gear, and like so many things I've ran into on this metal planer, the shaft that goes through here is kind of an oddball size. It is 1 inch and 1/64 of an inch, so a 64th of an inch over 1 inch. Now I've got a inside bore mic. If you've never seen one of these, there's 3 little points on there, and when you turn your barrel on here, it moves those in and out, and this is really a handy tool for measuring a bore, because you're getting on those 3 points. It really lets you get a good accurate measurement, and when we measure this out, it comes out to 1 inch 156.5 thou, and 1/64 is 165 1/4 thou. So it's just barely over that, and that's what we're going to shoot for, is 156 and a half is what we're going to shoot for. Let's see where we're at now. So right now, I'm not even at 1 inch, so we are about 6 or 7 thou under an inch. So I'm gonna go ahead, I think we'll cut another 30, 40 thou and just kind of sneak up on that last number there. One thing when you're boring, because of the way that arm is on there, the boring bar, it's always going to have some flex in it. Even a really big boring bar is going to have some flex in it. So as you get closer to your finished diameter, make lighter and lighter passes, so you'll have less spring in there. If you go in there and if I went in here and said, well, I need to take out 56 thou, I'm going to take out 50 thou, and then I'm going to come back in, I'll measure it. Yes, probably going to be right on 50 thou. Then I dial in 6 thou. Well, guess what? There was a lot of spring in that 50 thou. The next pass is probably going to take more than 6. So I like to just, as I get closer to it, make lighter and lighter passes. So we're at a 1 inch, 25 thou, just a tad under 25 thou there. When you got a little bit more to go here. I am right at 46 thou over an inch. We're going to 53. So I got 7 more thou to come out. All right, let's see where we're at here. I'm gonna come in, shooting for 153. There's 51, 2, 53. The original was 153 and a half. We're at about 153.7 here, so a couple of tenths over. Not gonna matter for what we're doing here. As we go down in the bore, it's almost right on 153 and a half. So got a couple of tenths variation in there depending on where we measure, but that bore is done. So next we need to do a little indentation here. This, there's a ring kind of around the center part here. It's 50 thousandths in from the, basically the flat across those teeth. And it's also about 50 thousandths wider around there. So I am going to just use my boring bar to come in there and do that. I'm just going to come in here. I'm going to use a dial indicator to go in my depth. I'm going to do about 25 thou. All right, we're touched off there. And I need to read another 50 thou on my dial. 20, 40, 50. I'm gonna go in my total 50,000 steps now. Do the same thing again. 20, 40, 50. Just gonna go in at 50,000 steps. Should have about 50 thou more I need to cut off of this. Let's see what we got. actually about 40 thou. I'm gonna dial that in. All right, this should be about 1.2, and the depth should be 50 thou. Okay, we're good. I have the gear now mounted on an expanding mandrel. So if you're not familiar with these, this is basically two tapered pieces. This piece here's got some slits in it that kind of make it like a spring, but they're both tapered so that wherever this piece here is on the mandrel up underneath it, it's always parallel ways here across from one another. So it's infinitely expandable to whatever size you need within that range. And I've got it mounted on this. I've got it purposely set right now where the end is kind of sticking out over the mandrel because I need to face the back side of this to length. I think once I do that, I'll probably move it more up on the center part of the mandrel where I have a little bit better contact on my center bore. The mandrel is mounted between centers, so I have a live center on this end. That means that it spins. It's got a bearing in here as a dead center on this end, which means that it's turning with a chuck. And we have a drive dog here that's bolted to the mandrel, and it's coming in contact with the chuck. So basically, as the chuck spins, it actually turns that mandrel. We're not just counting on the friction in there to do that. And with the part on here, first step is I want to face the back side of this and get that to length. Let me get a measurement on that and we'll get started with it. If you look, of course, we see run out down here. You really don't see any run out on this face over here that we had turned a while ago because it's all concentric to that bore that we did as well. All right, this should be 200 thou. I'm gonna get another measurement and we'll know exactly how much we need to take off here at the very end. Yeah, so I need 30 thou, which is exactly what I said a while ago. So I'm gonna dial that in. All right, so I just dialed in 30 thou. That should be it. Right on the money. All right, I've remounted this on the mandrel where I've got full contact in there now. Since this is the length, I don't have to worry about facing that back side anymore. Next thing I'm gonna do is go ahead and start trying to true this up. I need that turned down to what diameter? So the original is basically 2 inches. It's a little under that, and we got about 2 1/4, so we got about 1/4 of an inch to take off of that diameter. Let's come in here, we'll touch off, and start turning. This goes in, needs to go in 1 3/8 inches to that shoulder. So we're about 250. I need to go in another 75 thou. I'm going to again use my dial indicator over here to kind of help me do that. I'm gonna come out. Just kind of face it in to get to the proper depth. So I need another 12 thou. All right, let's turn that down to the right diameter. I need another 20 thou. Next step is I want to cut this back angle back here. So if you look at this, this is 90 degrees across this face to drop back off to that back. I know that this angle is 29.4 degrees, I think. So to get the 90, we subtract that from 90 degrees. I set my compound to 60.6 degrees. I'm estimating the 0.6 degrees, but we should be close. And what we're gonna do now is to start machining that out. And I want to take that back angle all the way back down in that bottom corner down there. So we're just going to slowly take our time and whittle this out. That, we got our back angle done. Got my angle set again. We're gonna redo this face here, not redo it, but get it to the right dimension, I guess would be the right way of saying it. We need to be at 2 inches, 492 thousandths on this diameter, this outside diameter of the gear. Right now, we are up around 2.7 inches on that outside diameter. So we got a fair amount to take off of that, and let's get at it. And for the final step, I came in here. I couldn't really get a shot of this because I was having to get down there real close to it to see what I was doing, but I cut a 90-degree face just kind of going in, kind of matching again this little bit of a face right here. So that's in there now. I think we've got everything to the right sizes. Everything should be good. I think our blank is done. And just like that, I think we have our bevel gear blank cut. Well, there you go. The easy part is done. We have the gear blank turned now. And up next, we'll be actually cutting the bevel gears. And guys, I'll be honest with you, I've never cut bevel gears before. And I've been doing a lot of research, a lot of studying on this. There's not a whole lot of information out there on it, but I think I've come up with everything I need to do. It's a little bit more involved than just cutting a typical spur gear, at least using a milling machine and dividing head like I'm planning on doing. But I think I got the process down, and we'll be bringing you a video hopefully soon of doing that. Before I cut it in the cast iron, though, I bought me some Delrin plastic back here. I'm going to make a gear blank out of this plastic material and actually go through the whole gear cutting process just in here as a practice run because I haven't done this before and I want to make sure I understand the process completely. Again, it's fairly involved. It actually takes 3 different cuts on the milling machine to get the final tooth profile. So it's not like, again, not like cutting a spur gear. More on that to come though, and we hope to be bringing you that video coming up soon. And with that, guys, that will be a wrap on this video. As always, thanks for watching. Please subscribe to the channel if you haven't already, and those thumbs up and comments are always appreciated. And guys, we'll catch you on the next video.